All right, so we've looked at how to solve a system by elimination. But so far, all the problems that we've done, all you really needed to do was add, and the variables would already cancel, right? We skipped that first step of getting it into a position where that will happen. So what we're going to look at today is how do you make that happen? So if no variable will cancel when you add, okay, you have to first multiply an entire equation. So if none of your variables are going to cancel when you just add the equations together, what we're going to do is we're going to multiply an entire equation so that they will match. Okay, and as a reminder, our goal is that you need to have the same number but different signs. Okay, so let's take a look. So this guy right here, okay, if I look at, say, the x's, these guys have the same number in front of them, but they're also the same sign. So we have the same number, but we don't have different signs. So that's a problem. We're not going to be able to just add these together. So what I'm going to do is I'm going to multiply one of these equations by -1. Okay, because multiplying -6 by -1 will change the sign. And that's all that I need to do. So I'm going to do like a giant distributive property. I'm going to distribute this -1 to everything in this equation. So -1 times -6x is +6x. -1 times +4 is -4. And -1 times +4 is -4. So really all that did was it just changed the signs of everything in the equation, right? Same equation, but different signs on everything. All right, and then from there, what I'm gonna do is now we have them set up right, but they're not like lined up, right? So I'm just gonna take the second equation here, this guy, and I'm just gonna recopy it down here so that everyth's nice and lined up. Okay, and then just like normal, we're gonna add, right? So 6x and -6x, those cancel each other out. And then -4y and +4y, those cancel each other out too, right? So on this side, I'm left with nothing. And on this side, -4 and 4, well, those cancel each other out too, right? So I'm also left with nothing here. So what that tells me is that this is one of my special situations, right? My special cases. All of my variables canceled out, and I'm left with something that's true, right? 0 does equal 0. We didn't get something silly like 10 equals 3, right? We got something that's true. So what this tells me is that this problem has an infinite number of solutions. Okay, so there are an infinite number of pairs of numbers that will make both of these equations true. All right, so that one was pretty easy because we got to shortcut. Anytime those special cases come up, you get to kind of skip a couple of steps, which is sort of nice, right? So let's take a look at this guy. Now on this one, right, these two have different numbers and the same sign. So that's backwards of what we want. These two have the same number and the same sign. So we need to change this so that they're going to be, one of them is going to have a different sign. So I'm going to do the same thing. I'm going to multiply one of these two equations by -1. So I'm going to distribute here. So -1 times 2x will be -2x. -1 times -7 will be +7y. And then -1 times 5 will be -5. Okay, so again, all that happened is I just changed the signs of all those numbers. Okay, I'm going to recopy the second equation below it, just so everything's nice and lined up. Okay, and then we're just going to solve this. So -2x plus 4x is 2x. +7y and -7y cancel each other out. And then -5 plus 3 is -2. Okay, and now we're left with our baby equation that we're going to solve, right? So I'm going to divide both sides by 2 to get the x by itself. So x is -1. Okay, and then from there, we're going to go back and plug that into either of your equations. You could use either of these two equations, or you could even use this one if you wanted to. Okay, so you could use any of those equations. It's just a matter of preference. I think I'll use the top one. So I'm going to do 2 and then times the x we just found, -1. So this guy got plugged in here. There goes my rolling marker. -7y equals 5. So that's this top equation before I multiplied it, right? Same thing, but I substituted the answer we got in for the x. And then we're just going to solve this. So 2 times -1 is -2, right? And I'm going to add the 2 to both sides to get this to cancel. So -7y equals 7. And then I'll divide by -7 on both sides. Y equals -1. Okay, and then last but not least, don't forget, you just got to make sure that you write your final answer. Make sure you write it as a point, and you need it to go X and then Y. So they have to go alphabetically. So this guy first, then this guy. And that's our answer. So that is the pair of numbers that will make both of those equations true. Okay, so again, the thing that you're looking for is they have to have the same number but different signs. Okay, so like that's how we knew with this guy that I wasn't going to get for the x's, I was shooting for the y's because those had the same number, and then I just had to make them be the opposite signs. And that is how you solve by elimination.